Okay, so welcome to today's video. Today I decided to start up a new series where we're actually going to explore the internals of Nanos itself. Um, I'm wandering around in TFS, which is the file system files, and what you'll find a lot is this func.ss. In fact, we can just kind of do a search for that real quick, and you can see that it's used everywhere. Now, if you've used C before, you're probably already guessing what exactly it is. And basically, it's our version of a existing C macro that that shows you what function you're in. So let's just pull this back up and look at this. So, when you're debugging, in fact, this says TFS debug, right? Which is another macro. We, we can conditionally enable this logging, depending on if we want to debug TFS internals or if we want to debug something else. So it's super useful. So you don't like spam a ton of information, because being a kernel, there's lots going on all the time. So you don't necessarily want to see everything. Anyways, so why is this different from just, our underscore func macro? Well, let's check it out. I extracted this code from the kernel rather than trying to figure out what's from where. And basically, this deals with the fact that we converted everything over to a different string type instead of using using C strings, and that was a security thing that we dealt with. C strings are everywhere. They're all throughout libc. It's all throughout most other kernels. It's just a fundamental type, and it's technically still kind of here too, right? But using this type allows us to abstract things out to where there's less foot guns. Anyways, so that's what this whole func.ss is really there for. Because if we look at it, I said it was a macro up here. This is where we define it, and it does this is string, which passes a char star of our existing macro, right? And then we do the size of -1. And so if we look at is string, that's this guy down here. And all we are doing is passing in a char star, which is as shown right here. And we give it the length, which is measured in bytes. Now, bytes is something internal here. So we have our type def of a U64, but oh wait, U64 also is defined as an unsigned long. And so this basically, given the char star and given our bytes, is going to construct a new string with a length and a pointer and then return it. So we had called this, right? And so now we have this inside of a string. Okay. Now I kind of short-circuited this because, frankly, this goes on forever. And I'll show you what I mean. But essentially, we would stuff it into TFS debug or something like that, which we have defined up here as another macro. And then it's going to call rprintf and use VA args on it, right? Now, rprintf, this is kind of like where I chose to just kind of short circuit. And actually, you know what? We can even show you why. Let me just get into the code real quick. Runtime. I think it's format.h. Yeah. So we have a few other functions here. We have aprintf for passing in a heap. We have bprintf for passing in a buffer. We have rsnprintf, and we have rprintf. And you might be wondering, well, why do you have, multiple ones, and, why isn't it just like a printf at the end of the day? And why did I short circuit the demo? well, if we pop into format.c, we can kind of go down here and see what our printf is actually calling when passed to sstring, right? Basically what we do is we allocate a little buffer. We've got our vlist, and then we call our printf, and then we finally do this buffer print. But even that actually goes a little deeper, right? So here's our buffer print, and as you can see, this is kind of like where the rubber starts hitting the road. We do a console write and a klog write, and essentially, keep in mind this is a kernel. So at the end of the day, you know, we're wanting to print maybe to the serial, maybe to, you know, a file or whatever, but it's going to be a device. And so there is no there's no printf at the end of the day, basically, right? So we have to talk to the device itself, and that's why this goes a couple levels deep. But that's also why you have all these higher order sort of functions that call it. But we do it in a safe manner with string. So just something to get us started off on the Nanos Internals set of videos, and I hope you'll join us next time.